doing the demo. Okay. I'm happy to be doing the demo tonight. Yeah, on my side, I'm a DevOps cloud engineer. If you have any questions, please know we are all learning. I'm not necessarily knowing everything here. That's not the reason why I'm doing the demo. So I'm just doing it so we all share the knowledge and understanding and move all together throughout the journey. So yeah, please feel welcome to ask any question at any point. We'll try to answer all the questions as much as possible. Oh, I hope everyone can see the screen. Can you guys see?
Yes, I can.
Yep.
Awesome, awesome stuff. Cool. Yes, as we saw the title, so today we're going through some basic Kubernetes concepts, which suppose not necessarily gonna be too long, as I hope it doesn't take long as well. But yeah, IT stuff, you can't really predict at all times, but let's go through and see how we can find it. Cool. So, before I even get to this stage, please note this is not necessarily for people who are just starting to learn Kubernetes. Can be for anyone. It's for all of us as well to just assist each other to move across like this concept. So, if you feel like I maybe didn't explain something clearly, feel welcome to jump in and share your knowledge as well. Awesome. Cool. So with Kubernetes, I would like to start off with understanding what is containerization, which is like an important aspect when it comes to Kubernetes, together with some of the aspects we're going to look later on through the slides. So yeah, what is containerization and like why do we do it and how does it relate to Kubernetes? So as you can see here, this allows applications and their dependencies to be packaged into a lightweight, portable containers. So this means I'm sure you guys have been seeing when you build an application on your local, maybe Visual Studio or any other platform, you're able to build that so you can actually run the application. So now this is what we're doing here. We are doing this so we can be able to package whatever the application needs into like something lightweight and portable. So your friend with their machine or another developer can be able to run the application the same way, right? So think of it as cloud providers, AWS, Azure, or any other virtual machine or environment. If this specific application is built and packaged into this specific container, it's gonna be ran the same way and it's gonna behave the same way across all the environments. So this help us to minimize the problems of on my local is running, on AWS test environment is not running or any other platform. So we minimize all those troubles and just make sure if it can run on your local, can run on any other machine, can run on any other cloud platform. So the main or the popular containerization platform which is out there, we call it Docker. So this is the platform which help us build and package all the application and their dependencies into one single file, right? So that's cool, clean. From that, you can use that specific packaged application to run the application anywhere you want. So yeah, I just put why Docker. So yeah, it help us with the consistency of like how we build our applications. It help us with the portability, so you can deploy that application in any cloud provider, or in any virtual machine if you're using if you want to like get to be specific and then scalability. If you want to, and let's say it's a specific car system, if there is more traffic coming in, your containers can scale up so it can handle the traffic as well. And then if there is less traffic, it can scale down. So these are some of the reasons why we use Docker. But now think of it, if you have a specific system and then that specific system contains like multiple containers, right? It can be, you can picture it as a microservice architecture system. So it can have like maybe hundreds of containers running to at the end of the day to accomplish that specific application's goal. So through those containers, you cannot necessarily manage them easily. When one container goes down, how do you actually know that? How do you actually get notified? How do you know which one went down? And then how do you troubleshoot through that container which went down? So it becomes like really painful to be able to do that. Let's say you're dealing with a specific customer facing application, and then you are the developer around 3 a.m. one container goes down. Let's say the database container goes down on your microservice architecture. So that becomes a problem because you're not going to wake up at 3 a.m. and start troubleshooting. You don't even know where to start and touch. You still sleep. So we getting into a point where we handle this problem. So multiple containers are, so to say, difficult to handle without like a concept of orchestration. So orchestration is like an automated way of how we manage our containers. Yes. Can we mute that? Mr. Albert, can you, thank you. Cool. So orchestration is the management of like us making sure our container services and workload are smooth in terms of operation scalability and fault tolerance. So this is the process or like the concept of where like our containers like relate to Kubernetes, right? So Kubernetes is our popular orchestration platform or system. So that's why here on the right side, you see the Kubernetes image. So why Kubernetes? So this is another short way of writing Kubernetes, automated scaling of our containers, right? Can manage millions of containers in just one cluster, and then you are able to monitor and log whatever each container produces. If like it fails or anything like that, Kubernetes as well has the safe self-healing, which means if a container goes down, Kubernetes is always going to try to make sure that another container running the same application is up again. So these are some of the solutions we have. I'll just like summarize there so we can just move forward and like have the basic understanding. Cool. And then cool. On this demo, we're just gonna keep it simple. So we're just gonna use Docker desktop, and then we're just gonna use another tool which make us interact with the Kubernetes API, which is the kubectl. So Docker Desktop, I'm sure like most of the guys like already know. It's just a tool which you install, download, install on your local machine. And then I'm not sure if you guys know, but pre-built it comes with Kubernetes as well. So that's why we're not gonna make anything complicated. We're just gonna move forward with Docker Desktop, and our images as well are gonna be inside Docker Desktop, which is exciting as well. And then the kubectl. It's a command line interface which we a command line interface tool which we're gonna use to communicate with our um, Kubernetes cluster. And then whatever we're going to be doing on our local Docker desktop, you can do it on any virtual machine, which is quite exciting because if this solution we're going to build on our local, if it can run fine and no troubles, if you can monitor and do everything, we can as well clone it in maybe Azure, AWS, or any other cloud platform exactly the same way we have on our local. So that's another nice thing about Kubernetes. It's not necessarily and like it's independent. It's not necessarily bound into like a specific cloud provider. You use the same YAML files, or we just call them scripts, in all these different cloud platforms. So your application like is guaranteed is gonna run the same way across all the cloud platforms. Cool. And then from here, these are at least the 8 concepts which we're gonna look into today. We're gonna, number 1, look at the cluster. Number 2, look at the pod. 3, service, replica set, deployment, persistent and volumes, ingress, secrets, and config maps. So on the right, if you can see, this is a simple architecture of like a Kubernetes application running. So on the left side, we have the master. That's where everything is controlled, and that's where you actually write the CLI commands to. And then on the right side, we have our nodes. And then inside the nodes, we have our pods. And then we have the kube proxy and then our kubelet as well. So these are some of the functionalities which each node would probably have. And then it helps with communication and making sure all the pods are healthy and at least there is like pods running depending on how many you want to run at a specific time. But for now, what I'm not about this, let's just look into making sure we understand these concepts. Cool. So here I put in some small definitions. I just tried by all means like to make sure keep it simple. I don't entirely make paragraphs and all of that stuff. So cluster, this will actually be, if I go back here, so here this would probably be a cluster. So it's gonna contain what the collection of nodes, can be worker node, can be master node. We're gonna get into this later on for running the containers. And then a pod, it's the smallest deployment unit in Kubernetes. So this is actually what runs the application. And then we have a service which exposes the pod as a network service. So it's either if you're exposing that specific pod internally in the cluster or out to the outside world where you can be able to access on the browser that specific application running in that pod. And then we have a replica set. This ensures the desired count of the pods you specified, it's always met. So if one pod goes down, if you specified you always want 4 pods running. So if one pod goes down and they get to 3, the Kubernetes is gonna try and bring and spin up a new one. And then deployment, this manages the replica sets for the app update. So if let's say you're working on a bug fix and now there is an update for that on that specific application running, you use this help us to manage those updates and make sure our application is never experiencing any downtime. Um, and then the persistence and volumes, since we're running our databases and everything through containers, it means if a container goes down, whatever was running inside that container, or let's say rather say pod, goes down with it. So if we didn't save or persist our data, let's say it's my SQL or SQL server, whatever was inside that database will be lost as well. So this is a concept which make us save that specific or persist that specific data after the pod lifeline goes down, and then we have the ingress. So at least these controls like for us like on how the outside world accesses the services inside our cluster. And then here is the secrets and config maps. So this is how we handle the sensitive information, like secrets, can be any keys, and then some configurations as well. So these are at least what we're gonna cover today. Then I'll move on from here. Oh, and then from here, at least we had enough of like the theory and like the words and all of that. So let's see how our YAML scripts are, and then let's see our microservices for this specific demo. So I'm gonna pause a bit here, and then if there is anyone with a question, whilst I bring up video code, please do jump in. Mhm. Yes, I can hear you. Okay. I thought it was a question. That's fine. So, um, I'm gonna start really simple here. So I'm just gonna take this down so we don't see. I'm gonna focus on whatever we have here at the top, right? So this is like a basic deployment, or a basic structure of like how our deployment can look like. Um, so remember we mentioned we have a pod, we have a replica set, and then we have a deployment. So now, here when you are configuring your Kubernetes or like your specific application or microservice, you can always choose a kind there. But first you choose the API version. So most of this stuff, they're out there on the Kubernetes like website itself. So if you go there, you're always gonna find the different versions based on the kind you actually trying to configure there. So here on the kind, you can specify a pod, you can specify a replica set, and then lastly, you can specify a deployment, right? So these three, they are different, and like there is pros and cons into choosing either one of these. But now this is the smallest deployment unit, right? And then there is a replica set, and then there is deployment. So how I like to explain it is a replica set can contain many pods, and then a deployment can contain many replica set, or a deployment is the one which manages the replica sets, and then a replica set is the one which manages the pods. So if you didn't want to use a deployment or replica set, you can just specify a pod. So remember, a pod is what actually runs your application. So if you specify a pod, then you won't necessarily have that replica set there. You're gonna have something like this. So if you have something like this, it means your application is only gonna be running one pod. And then it means like if that pod goes down, you can experience downtime from like the application as well. It's not necessarily um the best way to go about it. And then you can have a replica set specified that way. This is good, but it's not necessarily the recommended way. The problem is when you now wanting to roll in updates on your system, it's much difficult to like not experience downtime. Let's say there is a new update on a specific system. If you specify the replica set, it might like maybe probably kill first the pods which are currently running before it even checks and like make sure the new version is actually gonna work fine. So which makes us only remain with the best option, which is the deployment. Just a sec. So the deployment make us be able to make specify the replicas. It means how many pods you want to run at a specific time. And then it makes us to have a roll-in update for us for the vision of that specific application, which means if there is a new update, it's gonna create a duplicate pods on the side, which are gonna try to run a new update on that specific application. And then if everything goes well, it's gonna terminate the old one to make sure we don't necessarily experience any downtime. So cool. So those are the differences you can have when you specify the kind there. And then this is the metadata. This is just the name of the deployment. So that's the name you're gonna give it. And then from here, you have the selector. This is another important aspect I'm gonna explain later when we get to services. But for now, just keep it. So we have the selector, which has what match labels, and then we specified app and then the queue. So these are the key pair. And then here we specify the replicas. So if we want our cluster to always here on this deployment to always run 5 pods at a time, we specify the number of pods there as 5. So it means if one pod goes down, maybe because of memory or whatever reason will be, the Kubernetes will always try to bring up another one and always make sure it's 5. But for now, I'm just gonna leave it as 1. And then here, this is just the name of the replica as well, which is gonna be Q. And then at the bottom, we specify the spec, which is the container section. So this is the container name here you have. And then this is the image you want to run in that specific container. So the image is what you build and package your application into. So this is basically your application into just an image of the application with its all dependencies and packages. Cool. So this is the basic structure. If you understand these, the other sections are really gonna be easy to understand. Does anyone have any questions around this?
Yeah, I have a question. It's also here.
Mm-hmm.
So, on this screen, which fields are mandatory? Or
So yeah, that's a good question. So most of this stuff you're not necessarily gonna be able to cram. It's much easier if you go through the actual website of Kubernetes. Then that way you're able to check which one is uh, are required and which ones are not required. But for example, the name, the container, you need to specify a container, the replica set. This you might need to specify, but some of the fields here you can always like make sure you check on the site before. So it's something which you always need to do, and like when time goes, you can even like specify it on your requirements on the application. You can always go for those.
cool, thanks.
I see Mandla has a hand raised.
Hi. I was a bit lost with the whole.
Not sure what's happening. Can you hear people, Mr. Speaker? Can you please mute? Can the guys who are not muted and not speaking, please mute? Yes, you can go again, Mr. Muth.
Hello.
Yes, we can hear you,
Yes, I can
Mandla.
hear you now.
I don't know why the. Oh, okay. Let me stop.
No, you can post your question, Mandla.
Oh yeah. Okay. I was just saying that I was a bit lost with what that YAML what's the whole YAML template does. I was a bit lost with what was happening there.
Are you still lost now? Do you need
Yes,
some clarifications?
yes. Yeah, I like the whole thing. Yeah, I am really lost. Mm,
Okay,
with,
okay,
yeah.
that's fine. Is there any other end? Okay, that's fine. So let's try again, Mr. Mandla. So these YAML files are what help us to describe what we want to deploy, like how we want to deploy our application, right? So remember we mentioned an image is going to contain your application and it's all of its own dependencies. And then what we describe here is the configurations of how we want to deploy our application. And then providing it with some metadata to be able to access or identify each deployment, right? So when we talk about workload, it's actually the the application running on like that specific virtual machine. It can be any cloud platform as well, but these assist us into deploying that specific application. I'm not sure if that helps or you still need more clarification.
Yes. I think I understand. So like you were saying before, with that kind, the kind tells you what method are you using
Yeah,
to
yeah,
like
100%.
deploy the application.
Yeah, 100%. And then we talked about the pros and cons for each of those methods.
Okay.
So remember we have a pod, the other ones are the replica set as well. So these are the other two options we have, right? But these are not necessarily recommended for production grade applications. So that's how we end up having deployment, because a deployment is the one which controls replica set, and then it's the replica set are the ones which control pods.
Is there a location where we could find the documentation for this?
Yeah, no, whether or not I've prepared a file which I'm gonna share in the group
Thank
as
you
well
so
with
much. Thank you so much
links
for
and
using.
everything. No worries, no worries. Um, yeah, so that's that. So this is just a simple one. If I can close this now. So now this is one specific application, right? Remember, we're building a microservice architecture. Uh, so this is one application, and then we have another one here. So we don't want to end up writing different YAML files for each and every deployment, right? We can just put everything in one file and then just separate with these three. So these three indicate whatever is up here is separated from whatever is below it. So if you can see here, we're separating this one. If you can see here, we're separating that one as well. So this is a document separator. So if we scroll down, this is another application, part of this microservice architecture. So this is just the position simulator. I'm gonna get into detail on what each microservice does, but for now, I'm just gonna show you this concept here and how we configure it to be run in the container. Uh, Same as here, we have a replica set. And then we have the name. The name of this specific replica set is position simulator. And then the select as well. This is important. You have the position simulator as the toolkit app, and then position simulator. And then the spec, this is the container. So a container can have environment variables. So a developer, for example, will tell you this container, there's environment variables named this, and then what is the reason for that specific environment variable. It can be anything really. It can be like an environment. For example, it can be test, beta, it can be any configuration based on what you need that environment variable for on your system. And then this is another image as well. It's not the same. It's not the same as this one. So it's another application bundled together into one image, into an image. And then we have another one here. This one is the position tracker. Same as the other ones, ReplicaSet, we just want one pod to always be running at the time. And then we specify the container, we specify the environment variables, which that it's gonna need, right? And then we have another one. So when you get to understand this, the work is just repeating, just duplicate the same thing. And then you change in the image, you change the environment variables, you change the names and all of that stuff. And then this is the actual web app. This is what we're gonna be interacting with. So on the web app, you have the environment variable, you have the container, like the container name, and then the image which that container is gonna run. And then the other common stuff, the metadata, and then the selector as well. So another exciting one is the how we run databases in a container or in our Kubernetes. So for database, you still gonna the API vision, if you can check, the API vision can differ based on what you're actually running. And then here you have the kind deployment and then the metadata. The deployment name, it means it's gonna have what MongoDB as a name, and then selector. You're gonna have app MongoDB, and then you're gonna only want one pod to always be running, so I specify that, and then the name of the replica set, and then you specify the container. So here, there is an image which is already built on the site. I'm gonna share with you a link as well. So we run this image in our container to be able to have the MongoDB, and then here we're gonna have a look at the here we're gonna look at how we mount volumes into that specific pod. So when the pod goes down, the volume is always there. Another pod can get attached to that specific volume, and then we'll continue with the data which we have before that pod went down. So this is the section which help us with that. So for example, if you're on AWS, we can attach an EBS volume here. And then if a pod goes down, that EBS volume is always going to be there. So it's persistent. So you can attach a pod to that EBS volume. And that data is retained as well. So here, this is on my local machine. I'm mounting on the path of data and then /db, and then the name of the storage which I'm gonna take you through is Mongo persistent storage, and then we have the volumes as well, which is the name. I've used the same name here as well. And then I have the persistent volume claim. So this is what at least I claim and reserve, or I'm probably gonna need these for my attached volume. But I will explain this later on. Cool. So that's that with regards to the workloads. There is something which I said keep in mind, which is the selector. So now, how do we expose this running pod or microservice to the outside world? How do we access it? So now, and then how do we identify it to whatever is going to help us expose this to the outside world or internally inside the cluster? So now we introduce something we call a service. I think on the slides I mentioned I mentioned it as one of the concepts we're gonna have a look at. So here, similar to the YAML of workloads, we have a document separator. So it means this is one service, this is another service, and so on. So now on our service is what, remember, help us to expose that running microservice to the outside world, for you to go in on a browser and type dot this and that, or using an IP address or whatsoever it is. So you specify what you are gonna, or how you want that microservice to be exposed. So now on the workload side, we have a selector here with labels of app queue. So each and every service which has an app queue, it basically means it's gonna be responsible of exposing this specific microservice or application, right? So for example, if we go to a position simulator, it has its own unique different name, which is app position simulator. So each service is supposed to point into app position simulator. Let me check the position simulator one. Okay, that one, it's not necessarily needed to be exposed on the outside world, but it's fine. We can have a look at the web app one. So on the web app, here is the web app. We have match labels, which is app, and then web app, right? So the service is going to know which deployment it's supposed to manage or handle. through the selector. We'll specify the selector on this side with app and web app, which is the same as what we have on our deployment. So this way you connect this deployment with this service. So this service is going to be responsible of handling the traffic for this specific deployment, right? So this is another important part which we have in our deployment. And then from the selector, we specify the ports on how do we want that specific container to be accessed. And then here on this one, the name is the HTTP. We expose port 18, right, into on our container. And then the node port is like the port which we want to use locally on our browser. So which is gonna be 3080. And then the type, which is the node port. So the reason why we're using the port which is a bit bigger is because we don't want on our local machine to have any conflicts with any other port which is currently active or which is currently taken. So we can just choose from 3000 going up. So that way we know there is no port of that number which is already assigned to something on our computer. And then the node port is for when you're running it locally. So there is a type which is different from this. If I can do this, we have something called cluster IP, and then we have a load balancer as well. So these are other types which you can possibly have on your service. So a cluster IP, so it means this service is only exposing traffic internally inside that cluster. It's that service is not going to expose, or that microservice is not going to be exposed, or it's not going to be accessed outside of the cluster. So it's internal this service discovery, right? And then the load balancer. So this is where on the production grade you will use. So for example, on your AWS, you're going to be using a load balancer to route traffic into your microservice and then attach the load balancer to a DNS, which now you can call it dot maybe my application.com. So your load balancer can be attached to a DNS with a specific name like this. So this is like now when it comes to like production. But for now, we keep it really simple. For accessing in our browser, we just use a node port locally. And then, for example, this is another one. And then the node port is port 3010. So this one is 80. And then here, this service it's an internal, it's not supposed to be exposed to the outside world. So we use a cluster IP. So other services are gonna communicate with this through the IP as well. And then we have another one with a node pod. And then this is the database one. So we all know here we're not supposed to expose our database to the outside world, but rather only to our back end and all of that and services within that specific cluster. So that's why here we have the cluster IP instead of a load balancer or node pod if it's local. And then based on the database using, there are different port numbers for those. So this is how you write your service. Writing a service is not as complex. But yeah, this is the basics. And then remember we mentioned we have storage, right? We want to persist the data stored in our running pod. So if that pod goes down, what is the data which was saved in our database stored? So now we store it in a persistent volume, which we specify here. So here it's another concept. So if I scroll up, so here we have a document separator, but these guys go together. So here we have the persistent volume claim. So here we just make reserving or claiming. This is actually the storage we want. and then storage class name. This is the name, and then the metadata as well there. And then the access mode is read only, write only, and then read write once as well. So you specify it there, and then the actual volume gets allocated with storage based on this the claim of what you actually wanting to reserve or wanting or you think you will use on your deployment. And then here you have the kind, which is the persistent volume. So remember the other ones, the kind was deployment, was pod, was ReplicaSet, was service, but for um, the persistent volume is persistent volume there, and then you give it a name, and then storage class name, you give it a name as well, and then capacity, you just mention you just want only 1 gig, and then you have the access modes, and then you have the host path. So this is the directory of where the volume is going to be reserved in. So if you were on AWS, these configurations are going to be different. So we have a documentation which has the configuration for EBS volume, for example, on AWS. And then you just change here. You don't need to change back here. So here you don't touch anything. This is just fine. You will just change on like what specific, is it local or what volume are you actually wanting to use? So this is how we do the persistence. And then from here, I'm not sure if I made any other changes, but I just want to jump into Docker.
Before you do that, Nhlamulo, maybe we can
Uh-huh.
take one question before you move on to Docker. So there's a question on the chat. Um so they want to know a lot of sharing this. Oh, thanks a lot for sharing this knowledge. I have a question. Is it always necessary to have one pod running, or this number will be specified by the developer or something?
Okay, cool. Thanks for the question. So it's not necessary to have one pod running. That depends on the workload which the specific application is receiving. Let's say you have a car wash on a Monday, you don't necessarily have a lot of traffic going into your system or your booking system. And then eventually your application start to be big, people start to recognize it. So now you need more firepower to make sure you handle all the traffic. So now you can increase the number of pods. You can make sure you have 3 pods. So it means it's three containers running at a time. So those are going to share the traffic workload across like amongst each other and make sure like not only one pod is handling the traffic. So if your application doesn't receive much traffic, you can just put it as one. I'm not sure if that answers your question.
Yes, they say thank you. Thank you so much. It did. Yeah, we can move on to the Docker.
All right, awesome. Jumping into Docker now. Cool. I hope on those YAML files I didn't make any changes to break whatever we're gonna be doing this side. But anyway, so on your Docker desktop, after installing it, you go to settings. You have an option for Kubernetes there. You can enable it. By default, it's disabled. Just make sure you enable that, and then you can start enjoying the command lines on the terminal here. So bottom right, there is an option to go to the terminal. So when you're here, remember we mentioned we're gonna be dealing with kubectl. So this is like a command line tool which we use to communicate with the Kubernetes API, right? So we can be able to create, delete, manage or logs and everything. So we start with the kubectl command. So whatever I'm doing here, you can do the same thing in AWS on an EC2 instance or on a virtual machine if it's Azure. You can do the same thing to manage your workload, your Kubernetes workload, which is like quite nice. So cool. Now, the first command we can try to run can say kubectl get all. So here we're just trying to say get everything which is inside that specific cluster, which is a cluster on our local machine, right? So if I hit enter, so we can see on our local cluster, there is nothing else which is running. This is just a default cluster service or cluster IP, which is always there. Basically means there is nothing running. There is no pod, there is no deployment, there is no replica set. Like it's plain, there is no persistent volume storage, right? So now I'm on a, I'm on this path on my local machine, right? So I have put my YAML files into my working directory into a Kubernetes folder. Um, and then when I am inside there, it means this command line can execute whatever, can be able to manage or modify, like not necessarily modify, be able to execute whatever scripts I have inside that folder. So if we want to deploy everything which we have, we can just run kubectl, apply, period. So there's a command line to make sure you apply everything, all the YAML files you have in a specific folder, right? Or in that specific directory. But if you want to specify each file, each YAML file at a time, you can specify it as well. For example, you can say workload.yaml or whatever file name it is. But for now, just to save time, you can just apply everything. So remember, everything includes what? It includes the services, it includes the, if I can open this. So these are the three files. So this is what actually applying when we said kubectl apply. So we applying whatever script, whatever code or script is inside these files. Cool. And then now we can see it created all what we have described in our deployment, in our service, and in our storage. So now if we can hit kubectl again, we can be able to check, okay, this is the pod for each microservice which we have in our YAML file. This is the pod for the MongoDB position simulator, the web app. But now we didn't specify any replica set or any pod. We just specify the deployment. Why? Because the deployment is the one which will handle our pod and which is going to handle our replica set. So there is no need when you specify a deployment to specify a pod or replica set or just to go with a pod. You just create more problems for yourself. So just use like a deployment that way. So that way a replica set is going to handle the pods, and then a deployment is going to handle all the replica sets which are there. And then depending on the number of replicas we have mentioned there, it's going to have one. So it's always going to have one or the number you have put there. So for all the microservices, we have put 1, 1, 1, 1. So that's why here you have only one pod. But if we put two, for example, on the MongoDB, because there is a lot of traffic, you're gonna see another pod just underneath this one with a different unique address or identifier there, but the name is gonna always start with the one we specify on the configuration. Cool. And then we have the service. Let me rather start with the deployment. So this is the deployment. From the deployment, we have the replica set, and then from the replica set, we have the pods. So now in our configuration, if here we change that 1.3, it means this side on Docker is going to try to spin up two other pods for that specific microservice, which we have specified 3 now. But for now, it's still 1.1. And then another exciting thing about it is when we change, if I go here, roll back this, when we change or when there is a new deployment of our application, right? If we go this side, you can see it as well. it's gonna create, let's say we have a new version of our web app. We have added a green button, we have edited some other stuff, and then we deploy the latest changes. This is not gonna be taken down up until a new one start running fine and healthy. And then when that one start running fine and healthy, then this one here is gonna start showing a status of terminating, and then eventually it will go down, and then users will start using the new one. So that's how our deployment is gonna handle new changes and all of that. And then here we have the desired is how many replicas as well we have specified. So we specified one and then current one and then ready. So the DB one takes longer because a database like takes longer to spin up. But let's try to run the command again. Now it should be ready. So there it is. So now if you want to check logs, you want to check you want to check configurations for each pod, you can do that, which you can just copy the name for that pod, and then I can hit kubectl. Don't worry about the commands. They're gonna be on the file I'm gonna share with you, and they're online as well. So you can just say, okay, let's see what kubectl. Okay, I'm sure I copied the space there. Try again. Kubectl describe code, then specify. Cool. So you do it like this. So depending on whatever you're describing, you mention it there. If it's a service, if it's a deployment or whatever it is, you specify it there, and then you put the name. So here you can see the container, for example. What is it running? What image is it? If you, let's say, troubleshooting and all of that stuff, you can check the how many times did it restart? What are the mounts, so the persistent volume, and then you can check the condition. So all the other information you're gonna need are here. And then if maybe the pod is failing, you can describe and check as well if this is what you actually wanted to deploy and all of that stuff. You can as well check um, the logs of that specific pod. So if anything is failing, you can see from the logs. But let me quickly show you the application itself now. Just a sec. So 127. So on your local Docker desktop, it's gonna probably assign it this IP address, and then this depends on the port number you have specified for that specific uh, application. So remember, for our web app, we specified on the service, we specified 3080. So that's why here, what is that? What's that tab? Just a sec. That's why here we are following that port number. So if we hit enter, then it's gonna show you whatever that deployment or that application is. So this is just a simple application to simulate track movement on the map. So we have three other microservices. We have the queuing microservice, which queues the position changes over time. And then we have the position tracker, which tracks where a specific vehicle is located. And then we have the MongoDB, which stores where that specific truck has been following its route. So it's going to store that as well, and what time was it where and all of that. And then we have the web app, which is what we're seeing here. So this is a microservice on its own. So these microservices are working together to achieve like whatever we're seeing here. So if I go back here, so if we remember on the deployment, we have this image. So this image describes the queue, the queue, our microservice, and then this image describe what the position simulator microservice, and then the position tracker microservice, and then the API gateway, and then the web app, and then the MongoDB. So each part of this solution is run through a microservice. That way, we don't like make the application like dependent on like components which can actually be separated. Um, so yeah, so we end up having like a microservice, which like these services are working together to achieve like whatever we are seeing on the screen. I'm not sure if you guys have any questions.
Oh, yeah, no, thank you so much, Nhlamulo. This was a wonderful presentation. Maybe one question from my side. So let's say, for example, if now we went and deployed only one replica, for example. So if, let's say, for instance, you spin up two or three of those replica instances of the application itself, right? So how do we know from which pod is traffic being served from, for example? So in other words, from what I understand, it's running three copies of the same application. I just wanted to understand from that perspective, uh, do all the pods serve the traffic, or does one serve the traffic? Can you just elaborate on that one?
So what handles the traffic is actually how you describe your controller, and the Ingress controller, which is the one which exposes itself to the load balancer, right? So let's say you have millions of containers running in a specific cluster. And then those millions of containers, let's say they need to be accessed outside of the cluster, right? Which is highly unlikely, but it's just an example. And then each one of those are running, let's say, 10 pods each one of them. I think this can cover your question as well. So this way, what we do is we specify inside the controller how we want to route traffic into those specific pods. And then that way, the load balancer, we're only going to use one load balancer, for example, to be able to handle all of those traffic without like replicating the load balancers to cover all the microservices. So we can just have one load balancer. And then in front of the load balancer, we have the controller, which inside the controller would start describing the routes which goes into what deployment. I'm not sure if that answers the question.
Okay, no, it answers the question. Thank you so much, man.
All right, all right. Is there any other question, Kash?
Thanks, Nhlamulo, man, for the presentation. That was very informative, man. I just wanted to understand there on the ports, right? Is it only working on HTTP only or HTTPS?
Depending on your solution you're building, let's say it's an email microservice, the protocol can always change. So it doesn't necessarily need to be HTTP or HTTPS.
Cool, man. No, thanks a lot for that. Sure.
Any other question, Kash?
Neo, do you have a question?
Oh, hi, Nhlamulo. Okay, I'm not sure if this is relevant, but I was going to ask about the limits and resource quotas. Is it necessary or important to set them when on your deployment?
Yeah, I think you can specify like how you want to, like how much resources you want. but you can just give that to Kubernetes to handle, like to manage all of those configurations.
Okay, then what happens if you don't specify those limits?
I think someone else can assist with this, but like how I see it is, it will just like what you deploy, it will just scale it up or scale it down depending on like the traffic or workload which is being experienced.
Yeah,
And then
maybe.
if a,
Okay,
uh-huh,
carry on, Nhlamulo.
I was gonna mention if a specific pod like the CPU or whatever resources like are really high, it can spin up a new one to make sure the traffic can still be handled. So there is monitoring and logging and all of those are self-healing. So those are function or functionalities like they help us with those scenarios.
And just to add on that, if let's say for instance, if you want to put on resource limits on there, you obviously like what Nhlamulo mentioned, to obviously protect your application as well, because you might have, let's say for instance, an application, I mean a pod that spins up. If you don't have resource limits there, it can consume whatever that is available to it, and it might happen that it consumes more than what it requires, for instance. And then your infrastructure might have some issues where you don't have enough resources, and then your application might experience bottlenecks, for instance. So you can essentially protect the infrastructure, say you can only consume up to so much, and if that is utilized, then you can spin up another one and so on. Just to add uh, on what Nhlamulo was saying there.
Okay, thank you. Thank you, guys.
No worries, no worries. Is there anyone else with question, guys?
Yeah, maybe just to add on that one as well. I think I'm just saying this because I had this similar situation maybe a couple of weeks ago, where I ran out of resources when I'm trying to deploy one of my application. So the quick solution maybe is to enable auto scaling on your worker nodes, or maybe try to increase the size of your worker nodes. You can do that manually, or you can use a CLI to do that. It's quick and very easy. And it doesn't affect the application at all because it will terminate, it will create um, a new node and then keep on removing the old one as soon as the one is available and running the application. So there will be no downtime for that.
Thank you. Are there any other questions? Before we adjourn, I know we went past the hour. We promised up to 8. Thank you so much for everyone who joined, and thank you, Nhlamulo, for sharing information with us. I mean, this was a kick-ass presentation. I actually learned a lot myself, or revived some of the skills that I used to use and I'm not using anymore. I think I need to go back to the drawing board myself. But yeah, just to highlight some of the stuff that essentially happened, like the meeting that timed out, for instance. As you may know, we are essentially using the free version of Zoom at the moment. We are in the process of essentially buying a license so that next time we don't cut this good presentations like this that share good knowledge that we can utilize and grow together as DevOps engineer or engineers within the cloud space. As well. So thank you so much. Takalani, do you have anything to add? Or Nhlamulo?
No, nothing from my side.
Nhlamulo?
No, it's all good from my side as well. But I just want to mention, so today we're just going through the basics which we deploying our cluster locally. So maybe some other time we're gonna dive deep into how we handle it on AWS, for example. But yeah.
Yes, yeah, definitely. That would be a nice demo to see. But just to answer some of the questions on the chat, why don't you use Google Meet? Yeah, last time when we did the presentation of basics in AWS, we used Google Meet. Same applies on there. There's a license limit. I mean, there's a time limit on the meeting as well. So we also experienced the same issues that we are experiencing now, where we had to create a new links for the members to essentially join that session, right? So like I said, How about we can continue towards buying the license? Yes, we're definitely looking into that. We've been hard at work with the guys that are essentially managing the group to essentially make sure that that comes through from our side. Yeah, no, thank you so much. Thank you so much for the positive feedback. And yeah, we're looking forward to more demos, more sharing of knowledge, and yeah, have a like a day or have a like a night. Thank you.
Thank you guys for joining. Bye-bye.
Cheers. Bye bye.